So today we're going to take a quick look at linear functions. Linear functions can have three different representations. They can be in the form of an equation, they can be in the form of a table, or they can be in the form of a graph. In the end, each representation always shows the slope and the y-intercept. For example, in the equation there, M represents slope. I've memorized it as M for movement. That's telling me how the Y's are going to move because of the X's. The Y's are the output, the X's are the input. If you change the X, the Y is going to change. So, very simple finding the slope in equations. Right there, the negative 2/3, replace the M and substitute it for the M. Negative 2/3 is the slope. Now we can interpret that two different ways, either negative 2/3 of a y for every one x, which the equation's showing us, or we can think of it as negative 2 y's for every three x's. That is telling us exactly what's going to happen to all the y's and x's. Meanwhile, the b is the y-intercept. I think of that as the beginning. That number is 6. That is, right now, if I put a 0 there, so like cover the x up on your screen real quick, negative 2/3 times 0 is 6. That y-intercept always happens when the x is 0. So now what's that look like on the table? Y-intercept always is the y that goes with 0. In this case, it's 6. And then the slope on the table, I can look at it a couple different ways. First, 3x's. If I add 3x's, I'm supposed to subtract 2y's. So 6 minus 2 is 4. The y's drop by 2. If the x's go up by another 3, so 3 plus 3 is 6. The y is going to drop another 2. 4 minus 2 is 2. The other way that slope shows up in the table, I've shown right here, 6 is equivalent to 18/3. If I'm counting by 2/3, I should be showing things in thirds. 18/3 minus 2/3 is 16/3. So it dropped 2/3 of a y for one x, minus 2/3 more for another x, so 14/3 minus 2/3 more, so on and so forth. And then lastly, hide myself, the graph is showing the exact same thing that the table and the equation are showing. Begin at a y-intercept of y is 6 when x is 0, and then we're dropping 2/3 of a y for an x, 2/3 of a y for an x, 2/3 of a y for an x. But that can also be interpreted as minus 2y's for 3x's, or 3x's causes a drop of 2y's. And then that still shows up. If I go increase by 4x's, I'm going to drop, if I increase by 3x's, I'm going to drop 4y's. Hey, negative 4 over 6 simplifies back to negative 2/3. Hope that helps, so that way you can tackle the next upcoming Khan Academies that I'm suggesting you look at again. Take care.